Hey, testing. Hey, everyone. Yeah, looks like we got a good crowd. Thanks for coming out, guys. Yeah, so my name is Jordan Andrews, and I'm going to do a presentation, or I'm going to show you how I troubleshoot multicast packet loss on the NXOS platform. We're going to start by some of the questions I would ask to understand the problem more, and then from there, we're going to figure out how we're going to start troubleshooting the problem, and then we're going to go through checking the multicast state from the receiver all the way to the source at every hop. And then after that, go through some of the tools and commands that I would use from the switches. So a little bit about me. I've been working in TAC for about 7 years, and 4 of those years I've been supporting the NXOS platform. I'm currently working as an escalation engineer, and I also am a training lead. Here's my wife and my 3 children, twins right here. We also have another one on the way, so we're pretty busy. I like writing original music and also playing Ultimate Frisbee. I mean, if I have the time. Okay. So when we talk about multicast packet loss, we got to think about, at least from my experience, we got to keep in mind that what we expect to be multicast is, when we start troubleshooting, may be different from what we expect. So for example, somebody may come to us with packet loss problem, but when we investigate more, there might be some multicast configuration issue in the path. So for that reason, we need to make sure that the control plane state is good throughout the whole path. That kind of issue tends to manifest itself as no packets received at the receiver, and misconfiguration is a common cause of that. Now, other possible causes of packet loss or type of packet loss would be partial packet loss, manifesting itself as like pixelization of a video stream, for example. Now, that's the kind of stuff that you would expect, and it would be caused by things like congestion or corrupted frames, or maybe an issue at the application. So the reason why I bring this up is we need to make sure the state is working. The control plane state is working through the whole path. We can't just jump, in my experience, jump to looking at packet drops. All right, so let me lay down a scenario for you that we can then start asking questions and troubleshooting. Our security cameras stream multicast data to a remote device. However, the multicast data isn't being received as expected. Now, when I'm presented with a problem like this, I'm looking for, I want to ask for a flow that is impacted by this. That way I can focus my energy on there and on that flow itself and determine if there's how it's broken. That means we need to ask for the source IP, the destination IP, and the group IP for that particular flow. In our example, the source down here would be the video camera. The video camera streaming the security camera, rather. And it's going to be streaming that video to a multicast address, a group IP. And there is a receiver with a destination IP that's going to use IGMP to elect to receive that multicast data. So with a flow, with the IP addresses of a flow, well, let's move on to the next question here that I would ask. Is the issue still happening? The reason why we're going to ask this is if the issue is not happening at this moment, we need to look at historical logs. It's going to change the way we troubleshoot. In our example, the issue is still happening, so we can look at the state of the switch as it's happening. Is the issue intermittent? Again, this is going to change the way we troubleshoot. If the issue only happens at night or 5 minutes at a time, we may have to be creative with how we collect data. In our example, the issue is not intermittent. Now, this is one of my favorite questions. What are we seeing to indicate multicast is failing? The reason why I like this question is it gives the person or the client the opportunity to provide evidence of that problem. And through that, we can discover additional information about the problem. Let's say they answer that question, that they are using a test laptop and they are setting it up to receive that multicast data, but then they show that the multicast data is not making it to, it's not being streamed. We're not receiving the video. So again, there's some things that we discovered about this, like about the application itself, that they're using a test laptop. Maybe we were expecting a server. But the key thing I'm looking for is that there's no video stream making it to the receiver, which would tell me that there is likely an issue with the multicast state along the path. So with that in mind, we know the issue is not intermittent, and that it's still happening, and that none of the data is making it to the receiver. So with that in mind, we can put our focus in checking the control plane state. That means, in my experience, the best way to do that is to connect to the default gateway of the receiver, which is another name for that is the last hop router, and we can work our way back towards the source, verifying everything along the path, make sure everything is working. Now, if you don't have the time to collect, to do this process, one quick thing you can do is collect this output here, mroute details, at all the PIM routers at the same time. This is a quick thing you can do, and after everything is said and done and you have time to look at that output, you can potentially isolate the cause of where the control plane state is broken. Okay, so let's go ahead and start troubleshooting from the receiver to the source. I'm going to go ahead and connect to the last hop router and verify that L3 and L2 is working to the receiver up here. In this case, we're connecting to North 1 and North 2 that are in VPC. And they are connected to the receiver through a VPC link. The receiver's in VLAN 1334, and these switches are the default gateway. We verified that. Let's say that everything is working. L3 and L2 is working from there. Then we want to go ahead and look at the multicast config on these two switches. Now, I'm showing up here, I'm displaying the North 1 output, but North 2 is configured very similarly. The first thing to look for is PIM sparse mode configured on the relevant L3 interfaces in the path. VLAN 1334 is where the receiver is connected. It needs to have PIM sparse mode. VLAN 8 is configured as well, but we don't know anything about that. I would note this, and then we can verify later. The next thing to look for is the RP address. Is it configured? In this case, it's statically configured with 10.0.0.1. Now, with this flow is using any source multicast, and with any source multicast, it's all PIM routers must be configured with the same RP address, in this case 10.0.0.1. But also, somewhere in the network there's going to be an RP, a rendezvous point, and that must be configured to use that same RP address. So we're going to take note of that, and we're going to make sure that every PIM router in the path is configured with that. So I would say the multicast looks good so far. Let's go ahead and look at the mroute table on North 1 and North 2. The first thing to look at is we have a star comma G that's present on North 1 and North 2. And that there is an outgoing interface, VLAN 1334. It's being populated via IGMP. Now, I mentioned briefly before that a receiver can elect to receive multicast data via IGMP. And this is indicating that that's happening. Now, the incoming interface is null. And what that suggests to me is that the PIM join process was unable to establish from the last hop routers here towards the next hop towards the rendezvous point. So this is a problem with the state of multicast, and I'm going to take note of this and then continue working towards the source. At this point, we are connected to north 1, north 2, and we need to go to the next hop towards the rendezvous point, which is 10.0.0.1. So I went ahead and filled out the topology, or updated it rather. We see there's a VPC link here, as well as layer 3 interfaces, VLAN 8. And remember, VLAN 8 had PIM sparse mode configured up here. So that's good. That's what we want to see. We're going to go ahead and look at the config down here. The first thing to note is that, again, look at PIM sparse mode and make sure it's configured on all relevant L3 interfaces. VLAN 8 is configured there. That's good. We have Ethernet 1/30. Again, we don't know anything about that yet, at least. We also have loopback 0 and 1, and I'll address that in a little bit. We have 10.0.0.1 configured as the RP address, which is consistent with the previous North 1 and North 2. Now, there is special configuration here called Anycast RP. And what this configuration does is it allows Core 1 and Core 2 to both operate as the rendezvous point. So if you were to look at the configuration of loopback 0, we would see this IP address configured on both North 1 and North 2. There's a second set of IPs here, and these IPs are unique on both of these switches, Core 1 and Core 2. If we were to look at loopback 1, one switch would have one IP and the other one would have the other IP. And this unique IP is used to sync RP-related information about the sources between the two Core 1 and Core 2. All right, so let's look at the MRoute table on Core 1 and Core 2. So the first thing to note here is that star comma G is missing. And this is consistent with what we saw on last hopper, the North 1 and North 2. We saw that incoming interface was null. And here we see star comma G is missing, suggesting that PIM join is not working as expected. Now, the other thing to note is what's called a S comma G is present on here. And what this tells me is that multicast data is being sent by the source to the first hop router. And the first hop router is sending a PIM register to the rendezvous point. And the rendezvous point is receiving that and building out the S comma G here. Now, the thing to note is that the Core 1 and Core 2, the rendezvous points, are not going to continue building out the multicast tree state until it has a star comma G present, meaning that there's a receiver that wants to receive multicast data. So we know that there's an issue with PIM joins not establishing between North and Core switches. What could be causing that? The short answer is that there is an unsupported topology here where PIM is being used over VPC. Right? We have the VPC link, and PIM is being used between these two hops. Now, this can cause issues with PIM traffic being dropped, as well as, or it may, but if it doesn't, it also may affect the traffic coming from the source to the receiver. It may drop if it's hashed incorrectly over the VPC link. What we need to do is replace that VPC link, and one common replacement is physical L3 interfaces. But we also can make the VPC VLAN into a non-VPC VLAN. So let's say that we make the change and the video stream is making it to the receiver. However, when we look at that video stream on the application, it is pixelated or there's choppy, the video is choppy. That would suggest that we have drops somewhere in the path from the source to the receiver, causing those drops. Now, before we continue troubleshooting that, you may have noticed that this topology isn't completed. And I mentioned before that we need to check the multicast or the control plane state from the receiver to the source and make sure everything looks good, is working. So I went ahead and updated the topology, and this may be a little bit jarring, the change here, but I simplified, removed some information to simplify. The rendezvous point was here, and the next hop is the first hop router, South 1 to South 2, and then the source is directly connected. Now, I don't know about you, but my experience with troubleshooting packet loss in general, whether unicast or multicast, is it's tricky to troubleshoot. It's tricky to identify what's causing it. And I don't want to be going hop by hop, checking every device, multiple commands to figure out what could be causing it. And even then, I may not be any closer to the root cause. For that reason, I want to isolate the issue to a pair of switches, or even maybe one switch. For that reason, I'm going to use whatever PCAP tools are available to me to do that. The first tool that we can use is we can run captures at the source and destination. This is a relatively easy thing to do. And if we were to run, let's say, run those captures at the source and receiver at the same time, we could determine how many packets were sent and how many made it to the receiver. Let's say, for example, that 100% of the packets were egressed out the source, but only 90% made it to the destination. Okay, great. We already know that. We already know that there's packet loss. How is this helpful? Well, let's say, for example, 100% of the packets made it to the receiver. That would suggest that there might be an issue at the receiver itself. Maybe the application is failing, or maybe there's congestion on the interface. So with that in our back pocket, we can explore span as an option for capturing packets to isolate. For those that don't know, span can be ran on each one of these switches, or any one of them, as long as you have physical access with the laptop. Let's say that we were, well, just a little bit more about span though, before we get into it, is that span allows you to capture packets ingress and egress at the ASIC level. So let's say I ran it at the last hop routers, but also a capture at the source and receiver at the same time. That's a lot of data points, and that's necessary if we want to isolate the issue. And we could do that at the RP or the first hop routers, but I chose the last hop routers here. Let's say, for example, 100% of the packets egress the source. We confirm that. And then we had 10% packet loss at the, only 90% made it to the North 1 and North 2. That would suggest that there's an issue before the last hop router. Same thing, we can isolate it after the last hop router. Let's say in our example, we saw all the packets come to the last hop routers, but only 90% egressed. That gives us good confidence that we've isolated the issue to North 1 and North 2, and we can focus on those switches. We can do a deeper dive there. Now, one thing to note is if you plan to use span to CPU to do this, you have to keep in mind that those span replicated packets will be punted to the CPU, and they're subject to being rate limited. That means that if you have a high throughput where you're capturing the capture points, a lot of those packets may be dropped. So it has to be low throughput. The other thing is that in VPC, only one VPC peer can forward multicast data. And in order to determine which one is going to forward and which doesn't, they're going to go through an election process. And the winner, let's say North 1, will forward out the VPC link. North 2 will only forward out the peer link, only to get it to the North 1. And this is to avoid duplicate multicast packets. This command here is useful to determine which switch won that election. Okay, so we checked that. What else can we check? We've isolated North 1 and North 2. The next thing I would check is, is the multicast data being punted to the CPU? If the packets are being punted to the CPU, then they're subject to being rate limited by control plane policer or COP. We can run ETH Analyzer at North 1 and North 2, and if we see any packets captured there, that means those packets were punted to the CPU. Then we can check control plane policer with this command to see which class the drops occurred on and maybe determine the cause from there. This is an example of ETH Analyzer, and if you were to capture these packets, what it would look like. Note up here that I'm using a display filter to filter on the multicast, or the group IP, or multicast IP. And here's an output of COP, the COP output, and each one of these is a class. And you can see if anything dropped at any class. If you do see drops, just keep in mind that it's historical, and you need to keep running this command while the issue's happening to see if it's incrementing or not. So after that, we're going to go ahead and look at the interface drops. And there's a few commands we can look at. The main command to use is show interface counters errors. If you suspect output discards, you can look at show queuing. And if you suspect congestion, you can use this command to check for that. So from this output, show interface counters errors, there's multiple possible reasons for drops, ingress and egress. And again, these are historical, so you want to run these multiple times while the issue's happening to see if it's incrementing. In this case, the interface we're interested in is having output discards. There we go. Okay, so we see output discards, right? We want to look at show queuing. Let's see. There we go. To see if there's any, if we do see output discards, we can look at this output to see more information about those drops. And again, if you're suspecting egress congestion, you can look at this command. The total instant used is 0, and that would indicate that the current egress buffer is not being used at all. Whereas this output here tells us historically what the max usage of the buffer was, which in that case it was maxed out, suggesting output discards were happening. Again, you may want to run this multiple times, maybe clear the counters while the issue's happening. Now, note that we need to keep in mind what interface we're focusing on, in this example 49, and look at unit 0 and make sure that matches the instance of the output here. So, all right, that's it. So just a summary of what we went over. We went over the questions I would ask to understand a problem better, and then how I would start troubleshooting the issue. In this case, starting from the receiver to the source, making sure control plane state is working. From there, we discovered that an unsupported topology was being used and fixed that. We were still having issues with the packet loss, partial packet loss. So we went over some various tools and commands to use to troubleshoot that further and isolate it. So. Thank you for joining me for my presentation. So right now, if we have any time, we can go over some questions.